Morning, guys. This is the last lecture for our class. So today we will be continue to talk about string and how you utilize the string functions. So let's recap on what we have learned last week. Last week we have talked about reference. And what is reference? You can think of reference like an alias name for your variable. So for example, the template or the format for declaring and initializing a reference is like type. Type means the variable type of your reference, like integer, float, long, and then your reference name. And then to declare that this is a reference, before a reference name, you need to write this n%. And then we're going to assign a variable to this reference. And then you assign a variable to it. So take note that when you are when you are declaring a reference, you need to assign it at the same time. And when you are manipulating the value of this reference, it has the same effects on the original variable as well. Why is that so? Because the reference and your original variable are actually the same thing. They are sharing the same memory address. So that's why when you change the value inside this memory address, it affects both your reference and your original variable. And then using this reference variable, we can do something called pass by reference when we are calling our function. So in your function, if your function has this following format, like function, and then inside the parameters, they have this is accepting a reference A and then a reference B. Then when you are passing in a variable to this function, you actually passing you actually are passing sorry, when you are manipulating this reference inside this function, it has the same effects to those variables which are being passed in. Right. So what is the benefit of this? The benefit is that this save memory space because we don't need to allocate new memory space for new variable. Actually, they are pointed. This reference is pointing to the same memory space as the original variable. And then at the same time, when you manipulate this variable, it has the same effects to the variable that you have passed in. We can look at an example previously. We have talked about one example. For example, the swap example. Okay, let's look at the swap example. So for swap, okay, let's look at the original swap example first. For the original swap example, you have a main function. And then inside main function, we have two variables, I is 3 and j is 7. And then we wanna swap the variable. We want I to be 7 and j to be 3, right? So we call our swap function. And what our swap function does is that it's accepting two variables, A and B. And then it's assign A to a temporary variable and it assign B to A, and then assign temporary variable back to B. So now A and B, the value of A and B are swapped. So A gets the value of B and B gets the value of A. But then there's a problem here. When we print out I and J over here, actually I and J are not being swapped. Why is that so? Because when we calling this function, we make a copy of I to A and make a copy of J to B. So A has different memory address as I, and B has different memory address as J. So manipulating data in A effect on won't have any effect on the data in I. So and also manipulating data in B won't have any effect on the data in J. So even if we do all this processing, it doesn't affect the data of I and J at all. So we need to either pass by pointer or we can do pass by reference. So let's look at an example for pass by reference. Yeah, this one. The the program is actually this all most of the program are actually the same. The only difference is this n% we added in front of our variable. So this n% make sure that we are passing it by reference. So I and A has the same memory space. J and B has the same memory space. So manipulating A or B has the same effect on I and J. So in this case, if we run it now, J is 7, I is 7, and J is 3. This is what we want. Although also last week we introduced a keyword, a reserved keyword called const. You can think of it like constant. Constant means it's something that cannot be changed. It's not like variable. Variable is something that can always be changed, can be changed. But constant is something that cannot be changed. So if we look at an example inside, so we have a main function define a number with value 7, and then we have a function a square function. This function is accepting a parameter n, and then we want to make sure that square wouldn't manipulate the data of n. It will just do its job. Its job is to return the square of n. It won't manipulate the data of n, right? We want to have this guarantee. How can we have this guarantee? We can add a constant. When we define the variable, we can define it as a constant. So that way, we cannot manipulate the data of n. If we try and manipulate it, compiler will throw us error. Let us try it. So here, square 7 prints out 49, and number prints out 7. And what if we manipulate the data of n here, n plus plus? So it says it throws error. Increment of reads-only reference n. So n cannot be manipulated because it is defined as a constant. So in this case, how about we define integer numbers as a constant? So, and then we try and manipulate it. Number plus plus. So you see compiler throws error as well. Increment of read-only variable number. So we are not allowed to update the value of a constant variable. Also, last week we have introduced something on character array. So character array is what we have in C programming language. But then in C++ programming language, we have something more convenient for us. This is called string. String is something more convenient to work with. So For character array, the traditional method to define a string. So for character array, they can only store ASCII keywords. Each character is an ASCII character. So ASCII character is quite limited. Last time we searched for it. So for ASCII codes, there are like 128 ASCII codes. So only these 120x characters are available. So like Chinese character, English characters are not available. And so it's quite limited. It's quite hard to, it's not that convenient to work with for a character array. So and then so you wanna introduce something more convenient. It's called string. So string is defined the header string is something already included in the standard library. It's written by someone else. There are a lot of useful string functions for you to utilize. So string is a C++, it belongs to a C++ standard library. And then it has constructor. Constructor is for you to declare to initialize a string. And then it has many other functions that allows you to manipulate or work with your string. So how can we declare a string? So these are some examples on how can we declare a string. So we can write string s1 equal 123 or declare a string pointer. This is allowed as well. So let's look at and we can try it by ourselves. So here we define a string s equal 123. And then we wanna print it out. Yeah, it prints out 123. And usually actually sometimes if you don't include the string header, it will throw error. But in our case, it doesn't throw errors. But it's better to include the string header. Okay, so we have successfully declared and initialized our string, and we have printed it out. It's very easy to work with compared to the traditional character string. Sorry, the traditional character array. That is harder to work with. And then there is something in C++, there is something called constructor. So constructor is like, there are many methods. Constructor is like a method for you to initialize your string. So for string, there are many variant of constructors. So there are many methods to initialize your string. For example, the easiest one, the default one, is that you initialize your string using equal and then 123. So this is the default one, the simplest one. And then there are other kind of constructor as well, other method to initialize your string. For this sample, let's say we have we are declaring a string called s2, and then immediately, instantly, we wanna wanna initialize it with a value from another string. So in this case, we are initializing s2 with a value from s1. You can think of it, it's like replicating the data, the value of S1 into S2. So S2 has the value of S1. This is one of the initialization method. Let's try it by ourselves. Now we're going to, we have S1. Now we wanna initialize S2 and then S2 got the value of S1. And then we want to print out S2. So when we observe the result, S2 should have the same value as S1 because now S2 is initialized as the value of S1. And then we can initialize with a substring as well. So for this case, so this means we initialize with an original string and then the index position and then the length, how much we want for a substring. For this example, if we take S111, print out S3. Now we got 2. Why is that so? So 1 is the starting index position. So the starting index is counting from 0, right? So 0, 1. So index 1 is 2. And then we want the length of 1 only. So we get the length of starting from this index and we get the length of 1. So it's 2. What if we get the length of 2? Then we got 2, 3, right? What if we start the starting index is from 0? Then we get 1, 2. Okay. So this is replicating with a substring or initializing with a substring. And then we can initialize with a C style character array as well. So for this case, you see, first we have defined a C style string, and then we wanna replicate this C style string into our S4, our string S4. So let's try this character. String and equal string S4. Yeah. If we run this, so this AJK is replicated to S4. So S4 is AJK now, right? So now we have introduced several methods for you to initialize your string. And then next, let's look into some convenient function that is being provided by this string header. So first we have getLine. GetLine means to read in the string being entered from, basically means to read the whole line from input. So get, if we define get line cin, and then we read into S4, then we print out S4. Now we can enter hello, how are you? And this will print out hello, how are you? So S4 got a value of hello, how are you? So what is getLine? How is getLine useful? So normally if we see or just do C in S4, C out. If you just see we read from input using C in hello world, what will being read is just hello, because when we using cin to read the input are separated by a space. So this is considered one string, this is considered one string. But what if we are being asked to read in both hello and word into the same string, right? We want hello and word are inside the same string. We don't want them to separate by space. So in this case, we need to use getLine. GetLine means getter to read the whole line. So if we read in hello world, so the whole line will be reading into S4 using getLine. This is when to choose getLine over just the normal cin. And then there is a keyword or function called add. So add is for us to retrieve the character value from a string. Let's say we have a string called today is Friday. And then using add 2, we get a value at D. Right? Because this is at index 2. So index 0, index 1, index 2. D is at index 2. We can try it by ourselves. So now we want to, already we know that S4 is AJK. And now we want to character C equal S4 dot add 0. And then print out C. So add 0 would be A, right? How about How about 1 and 2? So at 1 will be J, at 2 will be K. So that means it's returning the value at that index. The value at 0 is A. The value at 1 is J. The value at index 2 is K. So this is what A at does. It prints. So for this case, value at 2, 0, 1, 2, 2 will be D. So it prints out D. And then there is a simpler method. We don't have to use add actually. We can just use this bracket. So if we change this into S4 bracket 0, S4 bracket 1, S4 bracket 2. So it does the same thing. It prints out A and then J and then K. And so there is a hint here. When we retrieve the character value from a string, what we got is not a string. What we got here is a character. So S bracket 1 is a character. It's not a string. So that's why here, you see when we are retrieving S40, we are assigning it to a character C, right? And then would you use the brackets or should we still use at? So it's easier to just use a bracket. It's simpler, right? And then also there is a function to get the size or the length of your string. It's very simple. So you have a string called str. String dot size return you the length of it. Or string dot length return you the length of it. It's super simple to work with. Let's try it by ourselves. Let's say we're going to read in something, right? And then we don't know what's the length of S4 right now. So the length 1 equal S4 dot size. Length 2 equal S4 dot length. And then we're going to print out length 1, length 2. Length 1 and length 2 should be the same. It's just different method of getting the size. So I miss a semicolon. So they are printing out the size as 6. Because hello has 1, 2, 3, 4, 5, 6. Because hello have 5 characters and then one and then one ending like backslash G or the null character. I think we need to print out S4 first. Yeah. So try again. Oh, okay, so now it's correct now. Using getLine, we are reading it the whole line. So for this whole line, how many characters are there? There are 1, 2, 3, 4, 5, 6, which is space, 7, 8, 9, 10, 11. So there are 11 characters inside our string, and both size and length return the same results. Also, there's a function called assign. Let's say we define a pointer, a string pointer called PTR. And then we assigning a value to our pointer. And then also we have defined a string called S1 and another string called S2. And we can, you see, we didn't initialize our string with a value yet. So we can assign the value to it later. So we assigning hop to S1 and we assigning S2 to S1. Also, we assigning a pointer to S1. Also, we assigning a substring to S1. So whenever we are doing assigning, the old value will be replaced. So what will be left is what exists will be the new value. And actually, there is a short form for assign. We don't have to write this assign explicitly. We can just use equal. Like for pointer, we use equal, right? We can just use equal actually. So a better version or a more convenient version is to write like this: pointer equal dream, or S1 equal hope, S1 equal S2, S1 equal value of pointer. So for these examples, dream is replicated into the value for pointer, and hope is replicated into S1, S2, and then is replicated into S1. And then the value of pointer is replicated into S1 as well, right? So what will be the latest value of S1? The last value of S1 will be dream. Let's try it. See, the last value of S1 is dream. And then what is the value for S2? And the value of this string pointer. We got dream and then empty. Why is it empty? Because we never assign we never initialize this S2. So it's empty. And then the value of our pointer is 3. Also, there is an append function. Append is for us to like concatenate multiple strings together. For example, here we have a string S1 and we have a string S2 and we have a pointer, a string pointer with these symbols. So now we say S1 append S2. What we got is 1, 2, 3 concatenate with S2, which is ABC. So we got 1, 2, 3 ABC. And then we can concatenate again with 4, 5, 6. So append 4, 5, 6. Now we got 1, 2, 3 ABC 4, 5, 6. And if we append again with this string pointer, we got 1, 2, 3 ABC 4, 5, 6 and some symbols. Let's try this. Play it. Okay. Print out. Yeah, when we print it out, 1, 2, 3 ABC 4, 5, 6 and then some symbols. Is correct. Actually, there's a short form for this. We don't have to use append. So a much convenient way to use plus equal. It's like you are doing addition to a number, but addition for a string means concatenating multiple strings. So here, if you write, you can change it into plus equal. Plus equal 4, 5, 6. Plus equal. So we run it. So it gets the same value. Now you know what does if we do addition of string, it actually concatenate two strings together. For example, so S1 is 4, 5, S1 is 1, 2, 3, S2 is ABC. Let's say S1, let's say we have a string S3 equal S1 plus S2 plus S1. Then we print out S3. So what will be printed out is the value of S1, 1, 2, 3, the value of S2, ABC, and then the value of S1. So as you can see here, the addition in string is actually concatenating of string. And there is a question here. I think we'll go through it later in the homework session. There's another question here is to concatenate two strings. So we'll go through it later as well in the exercise session. And then there's another function for you to insert a value into your string. For example, already you have a string. Now you want to insert a specific character in a specific index, in a specific position. So this insert allows us to insert a string at a position. Let's look at some examples. So we have S1 equal 1, 2, 3, S2 equal ABC, and then a pointer equal 3 asterisk. Now, at the 0th of S1, we're going to insert another string, S2. So in this case, what will be printed out? At the 0th position, we're inserting ABC. So we got ABC 1, 2, 3. And then at the 1st position, the position at the position 1, we're going to insert dash dash. So position 0. Position 0 is A. Position 1 is B. So at the place of B, at the position of B, we're inserting 2 dash. So now the string becomes A dash dash BC123. And then let's say we want to append at the end of our string. How do we get to the end of our string? We can use s1.size. This means s1.size means the length of this string, right? So the last index is at the last index is the position after the last index is equal to s1.size. So that's how we can append to the end of our current string. So now we get to this index, the index after our last index, right? The index after our last index. And then we append it with, we insert it with the pointer value, which is triple star, the asterisk. We can try it by ourselves. See, first, S1 is ABC123, and then it becomes A dash dash BC123. And then we insert at the end of it, it becomes with the 3 asterisks. And then also there's another function called erase. Erase is for you to remove some values from your string. So if you, for your string, if you call dot erase, you need to give it a position. So starting from which position you want to remove something, you remove the characters, and then the length. Length means starting from this position, how many characters are we going to remove, right? So for this case, we have S1, 1, 2, 3, S2, ABC, and then a pointer. And then we're going to erase from position 0 and then 1 character. So in this case, 1, 2, 3, from position 0, 1 will be removed, right? And then how about another case? Later, from position 0, we want to remove everything. You see, we say remove all the correct. S1 size means all the correct, the length of all the characters inside S1. So we remove everything. Let's try this. It prints out 2, 3, and then later it didn't print out anything. Why? Because this S1 is empty right now. Its length should be 0 now after it being erased. If you print out this size, see, its length is 0. There's nothing inside this string because everything is being erased. Also, there's another function for replacing the value inside your string. So you need to tell the position, from which position, and the length. So length means how many characters starting from this position. And then a new string means the new string to be to replace with. So you can think of, let's look at an example first. So we have S1, 1, 2, 3, S2, ABC, and then pointer with 3 asterisks. So S1 replace at position 0 with 3 character with 321. That means from position 0, which is 1, with 3 character, which means 1, 2, 3, this 3 substring will be replaced with the new string 321. So when we print out S1, it will be 321. And then later, another replace operation from position 2, 0, 1, 2. Position 2 is 1. And we're replacing S2 dot size 3 characters. S2 dot size 3 characters. S2 is ABC, so it's 3 characters with S2 ABC. So we are replacing 1 into ABC. So let's try this by ourselves. Yep, if it prints out, this got 1, 3, 2, 1, and this got 3, 2, ABC. What if we replace at position 1, which is 2, and we're going to replace 2 characters only? Then what will happen? So now we get 1, 3, 2, 1. Why? Because 2, 3, we starting from the position 2, starting from index 1, which is we're starting from index 1 with 2 characters, and these 2 characters is replaced with 3, 2, 1. So we get 1, 3, 2, 1, right? So this is how replace works. Also, there is a function called find for you to easily find a substring inside your string. So this find will start searching from position, and then return the first time where this substring appears. Let's say we have a string S1, 1, 2, 3, ABC, and then you want to find a character 3. So the position will be 2, because the first occurrence of 3 is at index 2. But if you want to find a character 0, it returns, you can think of it returns -1, because 0 is not found inside this string. Can try this by ourselves. So 2 and -1 are being printed out. So this is correct. As 3 is at index 2 and 0 is not being found. And then there is also something called find first of. So find first of, we find the first occurrence of any characters inside this string. So inside this character, we have capital letter A, and small letter a. So the first occurrence is at index 0. Why? Because small letter a is found. Or there is B. Actually, this doesn't make sense. B is enough. No need to B, because you'll find a first of each of the characters here. Also, capital letter A. This is redundant as well. One capital letter A is enough. And there's a substring function for you to return the substring for your string. So let's say we have a string called ABCDE, and then we want to get a substring starting from this. This is a position. This is a position. We want to find a substring starting from index 1. So it returns BCDE. And then if you specify if you specify the length to be 3, then it returns BCD. And if the index position is larger than your string size, then it throws error. It's out of range. Let's try this. So see, it says out of range. But if we make it, let's say we get the last S4, S dot size, the last index, and so on. So this is last index. So you get E. But if you put S dot size, this is a throw error. Doesn't throw error because I think this is the null. This S dot size is at the null character. But then S dot size plus 1 is out of range. It's larger than the string size now. And there is a compare function. Compare function for you to compare whether two strings are equal. So if we have a string 1 and a string 2, and we write as string 1 dot compare string 2. If it is equal, it returns 0. Otherwise, it returns something else, right? So for this case, it doesn't return 0. Then as string 1 and string 2 are not equal. Or for this case, we're comparing 2, 3 box. Means starting from 2, we get 3 characters, and the string to be compared is box. So starting from 2, 0, 1, 2, this is 2. Compare, get length of 3, 1, 2, 3. Compare with box. So it returns 0 because they are the same. And what if string 2 compare with string 2 dot size minus 3? String 2 dot size means 1, 2, 3, 4, 5, 6 minus 3. Starting from 3, 0, 1, 2, 3. Starting from 3, get length of 3, and then compare with box. This also returns 0. Let's try this. See, the first case return -1. The second and third one return 0. That means they are the same. But then there's a short form. There's a short form for it. We can just use equal. So let's say we just compare equal S2. This returns whether it is true or false. Or comparing, or let's say S1 dot substring from position 2 or 3, comparing with box. This should be the same. Not same. Should be the same. So this one substring, we get a substring of S2, and then we compare to box. Oh, there's a typo. So this prints 0 means false. So string 1 not equal to string 2. While this one prints 1 means true. Because equal return a Boolean value, remember? So this return 1. Well, for this, it prints 1 as well. So this is true. So just now it throws error, right? So it's because the the precedence of this operator got mixed up. So it's better to put a parenthesis over all this calculation or comparison. Yeah. And there is a question here. So we want to check how many inside a paragraph, how many are there? So our paragraph include space but doesn't include the next line. And the length will be lesser than 1,000. First, we need to read in this paragraph. So we can use getLine because it doesn't include next line. GetLine can read the whole line, the current whole line. So we can define a string S and then we get the whole line. We read in the whole line. And then we define a starting position for finding is. And then we need to start looking for is. How can we look for is? We can use the find function. So s.find is, and then starting position means where are we going to start with? So of course we start with 0, right? So initially the position to start searching is 0. And then while it is found, we find something, it returns the next position of is, and then we increase the count. So if the is found, we increase it by 1. But then now this while is an infinite loop, right? This is an infinite loop. We want to make it finite. How can we make it finite? We need to have the ending condition. What is the stopping condition here? Is that when we don't find any we don't find any new is anymore, right? From the position, we don't find any new is anymore. Then we need to stop the while loop. And then actually every next time we have to start searching from position +2. So there is a typo here. It should be the closing parenthesis should be here. So this is a typo. So this should be s.find is position. So we get the we get the next position of is, and then we +2. Why +2? Because next time when we found is, next time we want to start searching from the index after is. So we +1 and then we +2. And then next time we start looking at the index after is, right? Right. So that's why we need to +2, and then we assign this position to our latest position. Let's say our position starting from 0, right? And then we found is at, if we have a field called let's say history. So position starting at 0. And when we s.find is starting from 0, we will find this, right, at the index 1. So now we will increase the count by 1. And then next time we want to start looking from this index, right? We want to, because already we found the first is, now next time we want to start looking from index t. So in order to do this, we need to skip the length of is. So we plus 2 and assign it to our next position. So next time, if we look again for this while, now the position will be 0, 1, 2, 3. Now the position will be starting from 3, right? So we look for next is starting from the index 3. So that's all for this. I think that's all for this lecture. Let me clear it. Clear my notes. So we have talked about a lot of functions, a lot of useful functions for string. And this is the last lecture for our course. So we have covered all our lecture content. And let's take a rest for take a short break until 10:05, and then we will start looking into some exercises. Hello guys, let's start our exercise session. So I think we have go through this last week. This is asking to observe or to convert these ASCII characters into its ASCII codes. So for 0, it will be 48, 9 will be 57, and small letter a will be 97. Try run this. Yeah, this is how we convert an ASCII character into its ASCII codes. And then there's another question asking us to convert a small letter into capital letter or capital letter into small letter. We have go through it already last week. The next question asks us to invert a string. So given A, B, C, D, we need to invert it or revert it into D, C, B, A. So given a string, so how can we do so? We need to swap. We can swap. So we start reading from A, and then we swap A and D, and then we read B, and then we swap B and C. We swap the first character with the last character, and then the second character with the second last character, and so on and so forth. So this is how we do it. This is the theory behind reverting this string, right? So first we need to read in a string, and then we get the string size, and then we look from the first character until the middle. Where is the middle? The middle will be string length divided by 2. So this will be the middle point, the middle index. So from 0 until the middle point, and then we swap. We swap let's say the first character with the last character. How can we get the last character? It will be string length minus 1, because we want index, so it should be string length minus 1, because index starting from 0, and then minus I. So initially I is 0, so we got the first character. When I is 1, we want to match with the second last character, right? So this will be minus 1, this will be second last character, and then we can swap it. So this swap is provided by the standard library. So we can just use it. I think it's probably inside algorithm, but for our editor, it works without including this header. So we can just use swap. So that means you don't have to write your own swap. You can use the readily available one in the standard library. So if I write A, B, C, D, E, F, G, H, I, J, K, L, what will be printed out will be the reverse of A, B, C, D, E, F, G, H, I, J, K, L. So it works. Also, another question is, the user is entering two strings, A and B. So now we need to get the first part of A, the first half of A, and then mix with the second half of B. We concatenate them and print it out. If the string is if the length of the string is an odd number, then we concatenate the whole string. For example, we have ABC, small letter ABC, and capital letter ABC. So this is A, this is B. Because their string length is an odd number, it's 3. So we concatenate the whole string, small letter ABC and capital letter ABC. And however, if it's an even number, the string has the length of the string is an even number, A, B, C, D, E, F, G, H. Then we get the first half of A, B, and the second half of G, H. So we get A, B, G, H. If we input G, G, K, K, B, B, C, C, then what should be printed out? It should be G, G, C, C. And how can we do so? First, we need to check the length of the string, right? And then later, we can get the substring. If for this case, we need to get the first half or the second half, right? We can use substring, right, to get the first half, and also use substring function to get a second half, and then we can concatenate them. But concatenation is not hard because in string, the addition, the plus symbol is actually concatenation, so it's not hard at all. So let's go back to implementation part. We need to define a string A and a string B. And then we read in A and then read in B. And then we need to get the size of A and B, right? So if A has an even, we check whether the length of A is even number. How can we check? So if A length modulo 2 equal 0, that means A is an even number or B is an even number. If both of them are not even number, or if either of them is not an even number, like if either of them is an odd number, then we concatenate both of them. We concatenate A, B. Right. Here is a trick. We just print out A and then following by B. But then also we can define a third string or S or result. So result equal A plus B. And then we print out result later. Right? And then same for here. If the string is even number, right, then we need to concatenate the first half of the string A. How can we concatenate the first half? So starting from for substring, the index should be starting from 0, and then the length would be the size of the string divided by 2. That is the length of the characters we want. Plus B the string. For B, we start reading from the second half. So the index for second half is B length divided by 2. And then we can run this. ABC, ABC, prints out ABC. So they are being concatenated. ABCD, EFGH. So this prints out ABGH. How about GGKKBBCC? So this prints out GG and CC. So as you can see, the string function is very powerful. Oh, so already we encountered these questions in the lecture just now. So this person wants to search how many is appearing inside our paragraph. So I think we have go through this already inside the lecture. So let's skip this. Okay, and then there's this function. Given a positive number n, verify whether it is a multiple of 11. So the hint is if the number is a multiple of 11, then the sum of the sum of the number at the odd position and the sum of the value at the even position will have a difference, and this difference will be a multiple of 11. So the hint here is telling us to add up all the numbers in the odd position and then add up all the numbers in the even position, and then we check the difference, which means we do minus, and then we check whether this difference is a multiple of 11. If it is, then return true, otherwise return false. So for this case, we can read in the number as a string, right? We read in a string, and then we need two variables to track the sum at the odd position and the sum at the even position. So, and then later we need to look through this string, right? And for each string, we need to actually get the integer value for this character, because right now it is in string format, right? We need to get the value of it so that we can add it up, right? So for example, this 3, we need to change it into character format first, and then character is in ASCII format, right? And we need to get the actual number. How can we do so? We can minus by character 0. Then now we get the actual number of it, which is 3. So if, let's say, if I modulo 2 equals 0, that means I is an even number. Then on odd index, plus plus, otherwise even index plus plus, even index sums, sorry, plus equal the 3, otherwise this will pass for even position, and then we calculate the difference. How can we calculate the difference? So it's easy, right? Just minus, like odd index minus even number, or even minus odd. But then we want to make sure that this difference is a positive number, so that we can verify whether it's a modulo of 11, right? We want to make sure that it's a positive number. How can we do so? We use the absolute function. So this absolute function, I think it should be included in math header, but then for our editor, we don't have to include it using math. So we can just use it absolute, and then so this even if this is a negative number, this ABS function will convert them into a positive number. And then the last step is to verify whether this is a multiple of 11. If it is, then return true, otherwise return false, right? We can try to run this. For example, if it's 11, then true. How about 22? Also true. How about 1122? Also true, right? How about 3399? It's also true. What if 11 what if 1123? This is obviously false, right? This returns false. And then there's another question. So there's something called a Caesar password. So this method, it moves each character by k position to get the encrypted character. So our task in this question is that we need to figure out what K is so that we can get the original input. All right. So, okay, so for example, K is a number, okay? So for example, inside, these are all ASCII. You can think of these are all ASCII characters. So when 1 plus a K integer, it gets to star, right? Or from J, it plus a K integer, it gets to C. And also from 5, it plus a K integer, it becomes dot now. So we need to figure it out. What is K? What is the value of K? So what can we do? We can try J. For example, we can try 1 minus by star, or we can try star minus by 1, right? If we try 1 minus by star, let's say we try 1. So that means if we input a string which is this string is encrypted, we enter an encrypted string, and then for each of this string, we move its ASCII number by K value. And this K value is equals to, wait, to make it clearer, this K value, K value is equal to, so let's say we minus by K and enter. Yep, we get the answer. So what is K? Oh, so the K is 7, and we get the decrypted string now. So that means from each of these ASCII number, we minus by 7 can get us to the original decrypted string. So this is like an encryption puzzle, and we solve it. And this encryption method is called Caesar method. It's one of the simplest way to do encryption, but then it's not secure enough. Okay, so these are all the exercises. We have go through all the exercises, and we have finished all the lectures for our course. So thank you for listening, and wish you guys good luck in your competition in NSSPC. Thank you. Bye-bye.